Hello, everyone. I'm Stefan Bernat from Linköping University from Sweden. It's an honor for me and for my colleague, Somas Filis Karabag, to be part of this book presentation. First of all, we would like to present our congratulations to the editors on the final version of Frugal Innovation and its implementation. The book really provides an overall view on the topic for both academics and also for technology managers. That was a great job. We also would like to express our gratitude to the editors. Actually, we have to express that for allowing us to be part of the research at the last minute and allowing us to share our studies on this very interesting topic. Thanks a lot. So let me start presenting our chapter. I'm going to share the screen. Okay. So we are on the part 2 of the book, Frugal Engineer and Development Process. And we talk about fostering frugal innovation through computer-aided engineering, benefits and challenges for emerging economy firms. So we know there is a lot of strategies and practice of innovation being presented in the literature of developed and emerging economies. There is a topic, this topic of frugal innovation has recently attracted the attention of the scholars as a new model that is less costly, eco-friendly, flexible, and inclusive. However, most of the literature, the current literature, is focused on defining frugal innovation. So we had a different approach. The goal of this research, this study, was to explore some engineering product development process that help firms to create frugal innovation. So this is the topic of our studies, the role of computer-aided engineering technologies for fostering frugal innovation and how firms in emerging economies strive to organize their innovation activities when establishing and applying these digital tools. For the theoretical background and conceptual framework, we are working on the main criteria of frugal innovation: substantial cost reduction, concentration on core functionalities, and optimized performance level. We also work on the editors' ideas, who indicate that advanced technologies and digitalization are helping frugal innovation create low cost and high quality products. However, there are some impeding factors in emerging economies that are some kind of barriers to implement frugal innovation. So based on these ideas, we draw this conceptual framework. We have the computer-aided engineer on the left and the frugal innovation on the right. And they are moderated by the organizational challenges. This is the model, and we explore some cases using this framework. So we work on a multiple case study. We selected 3 companies in Brazil: Pluto Antennas, Jet Towers, and Senco. We went through interviews and also public documentation, and then we called the data looking at criteria, the frugal innovation criteria, some benefits, and also for the challenges to implement frugal innovation. So I'm going to start presenting the companies. I think this is the most interesting part of the chapter. So the first one, Pluto Antennas, is a small company. They work on developing microwave antennas and interfaces They work on the market of satellite antennas, wireless internet providers, mobile, RFID, and they have been using simulation tools since 2011. And are some pictures they use on the simulation. They work on some variables like frequency, geometry, dimensions. They work to comply with standards in the Brazilian agents, and they are able to design high efficient antennas and also interface to adapt radios and antennas from different manufacturers using digital tools. The second is Jet Towers. They have a background in telecom business since 2010, and they start this company in 2016. They have 12 employees and just one expert in simulation, and they work development and manufacturing and installation of cable-stayed and self-supporting metallic towers. They provide towers to serve the market of telecom, wireless internet providers, TV and radio channels, radio communications, mobile, and they start using simulation tools since the beginning, since 2016. We can see some pictures of the products and also of the company where they work with the towers. So looking at the simulation tools, they have some variables like the tower height, the type of antennas, the land dimensions, the type of antenna, tower, cable stayed or self-supporting, the soil resistance, many variables. They can identify some critical failures and oversized components. They can develop lighter metallic structures using these simulation tools, and also test new technologies, and also they work on the foundation of towers. We can see some pictures and how the simulation works in these structures. And the third company is Senko. They have a background in marine equipment in a long time ago. Since the 80s, they are working on agitators, mixers, dispersers, and mills. They have around 50 employees and just one expert in simulation. They provide equipment to serve the market of mining, chemical, petrochemical, pulp and paper, sugar, alcohol, food, beverage, and others. They use simulation tools since 2014. We can see also some pictures of the company. Many design variables, tank dimensions, chemical reaction, heat exchange, catalysts, impellers, density, viscosity, working regime, many variables. They work on trial and error, restrict to virtual prototypes, more effective solutions for forming problems. They had problems in the past, but now using this kind of simulation, digital simulation, they can achieve more effective solutions. They also develop new technologies, and they are able to provide solutions for complex problems that the physical lab was not able to solve. Many times they had to, they used to try to run some experiments in the physical lab, but they couldn't do that because the substance was too complex that the physical lab could not do that. So they are able to run that kind of experiment in the virtual lab. From these companies, we were able to collect data and reorganize the data on this table. Very interesting way to see and to look at this data. So on the left, we put the companies on the left side, and on the top, we relate the topics, the main topics, like the criteria for frugal innovation, substantial cost reduction, concentration to core functionalities, optimized level of performance, the benefits, the challenges, and also the outcomes that we have for each one of these companies. For example, the outcome here for Pluto antennas, they are able to deliver cheap antennas certified by the telecommunications agents in Brazil. Jet towers, they are able to deliver affordable, lighter, and high-quality metallic towers. And Senko, they can deliver high-efficient equipment with lower cost of ownership. Here, for example, we can see jet towers about the optimized level of performance. They are able to design towers to support winds of 200 kilometers per hour, working on the simulation tools. Looking for the benefits, for example, also in jet towers, they can learn much more about the materials, the connections, and of the metallic towers. They can deliver the product in a faster time to the market. And they also use the tool to show to the customers and aid sales. So in a very short way, we can see how the tools the digital tools can support this type of engineering companies. And concluding this topic of this presentation, just three parts. We see that CAI has a potential to foster frugal innovation because they can support all the criteria that we elect according to the literature. But not only that criteria, this kind of technology can provide further benefits like better decision making during the design of new products. It's easy to decide about how to build that component, that architecture. The tool also help the company on observe and learn about that structure, that chemical reaction, about the propagation of the electromagnetic wave. They can also deliver to the market in a reduced time, and also sustainable development because they can save resources even during the development and also during operation of that product. However, there are some challenges that organizations have to deal with. For example, it's not cheap to implement this kind of tool in companies. Both hardware and software, there is a cost to acquire and implement this solution. But the main critical challenge, I would say, the technical skills of users. Sometimes you need 1 year or even 2 years to have a very good technique engineer or a guy that will operate that tool. Otherwise, if you are not able to achieve good simulation results, then there is a risk. You develop a product that will not achieve the right criteria or the right requirements that were established in the beginning for that product. So there is a risk. So companies have to invest in hardware, software, and especially in people to training and make them able to use with guarantee that they will achieve accurate results in simulation. Okay, that's it. 50 minutes, and I hope have reached your expectation about this presentation. Okay, thanks a lot, and it's a pleasure for me. If anyone have some question, we'll be able to answer here. You can see my email and also from my colleague Somas Carvalho. Okay, thanks a lot for your attention, and see you.